Problem 7. A beam of helium-neon laser light at 632.8 nanometers is incident on a smooth flat germanium crystal at an angle of 16 degrees with a normal. The index of refraction of germanium at this wavelength is near 4.1. So here we have four things to find. What angles does the reflected beam make with a normal? What angle does the reflected beam make with the normal? What angle does the refracted beam make with the normal? What is the speed of light in germanium? Draw and sketch a showing of incident ray, refracted ray, normal, and germanium interface. I think it makes sense to start with D. We have to do it anyway. So let's create a drawing so we have everything here in front of us. And I'll do D over here on this side. So here we have the interface between the air, and here is germanium. The index of refractive index of germanium is equal to 4.1, and for air let's use 1 instead of the 1.0003. So here's the interface between these two different optical media, and let's draw the normal to the interface. Here's a normal. At this point is where we're going to have the incident ray. So let's switch to a different color. Let's use red. So the incident ray comes in at an angle of 16 degrees to the normal. So 16 degrees to the normal, it's about here. So this is the normal. Let's label it normal. This is the incident ray. Let's see here. This is the incident ray. And then this ray, because it goes from a thinner to a thicker optical media, instead of continuing on a straight path, right here at the interface it will bend towards the normal. So this is the ray which is refracted. This is the refracted ray. Also, at any interface you're going to have a reflected ray, and the reflected ray should be back into the medium which the original ray came from at the same angle of incidence. So the reflected ray would be at an angle of 16 degrees. Okay, this is 60 and this should be 60 degrees, and this is the reflected ray. So we have everything here on our diagram which satisfies D part and part D of the question. Let's move on to question A. What angle does the reflected beam make with the normal? Well, the reflected beam is this one right here, which has to be the same as the incident beam. So we can say that this is 16 degrees. So we have answered already that part. So this is the answer to A, is right here. B. What angle does the refracted beam make with the normal? So this angle right here is the one in question. So let's change colors now to green, And let's label now these angles: the incident theta 1, the refracted theta 2. This is the index of refraction of the first medium, the index of refraction of the second medium, and now we're gonna use Snell's law. So for B, Snell's law says that n1 times sine theta 1 is equal to n2 sine theta 2. n1 is given, theta 1 is given, therefore the sine theta 1 can be found. n2 is given, sine theta 2 is the only unknown quantity. So we need to solve this equation for theta 2. So let's first solve for sine theta 2, which will give us n1 sine theta 1 over n2, which will give us 1 times sine of 60 over 4.1. This is sine of theta 2. And if we do the calculations, theta 2 sine of theta 2 is equal to 0.211. Therefore, theta 2 is the inverse sine of 0.211, and theta 2 is equal to 12.20 degrees. So that's our answer for B. Question C says, what is the speed of light in germanium? Okay, let's see, we have another page here. So to find the speed of light in germanium, we start with the equation of the index of refraction of germanium, which is equal to the speed of light in vacuum over the speed of light in germanium. And we solve for V in germanium, which is going to give us C over the index of refraction in germanium. And now V germanium is equal to 3 times 10 to the 8th meters per second over 4.1. And this will give us 0.73 times 10 to the 8th meters per second. So the speed or the velocity of light in germanium is 0.73 times 10 to the 8th meters per second.